Dichromacy, di meaning two and chroma meaning color, is the state of having two types of functioning color receptors, called cone cells, in the eyes. Organisms with dichromacy are called dichromat. Dichromat can match any color they see with a mixture of no more than two pure spectral lights. By comparison, trichromat require three pure spectral lights to match all colors that they can perceive, and tetrachromats require four. Dichromacy in humans is a color vision defect in which one of the three basic color mechanisms is absent or not functioning. It is hereditary and sex-linked, predominantly affecting males. Dichromacy occurs when one of the cone pigments is missing and color is reduced to two dimensions. Classification. There are various kinds of color blindness. Protanopia is a severe form of red-green color blindness, in which there is impairment in perception of very long wavelengths, such as reds. To these individuals, reds are perceived as beige or gray and greens tend to look beige or gray like reds. It is also the most common type of dichromacy today. This problem occurs because patients do not have the red cone cells in the retina. Protanomaly is a less severe version. Deuteranopia consists of an impairment in perceiving medium wavelengths, such as greens. Deuteranomaly is a less severe form of deuteranopia. Those with deuteranomaly cannot see reds and greens like those without this condition, however, they can still distinguish them in most cases. It is very similar to protanopia. In this form, patients do not have green cone cells in the retina, which makes it hard to see the green color. A rarer form of color blindness is tritanopia, where there exists an inability to perceive short wavelengths, such as blues. Sufferers have trouble distinguishing between yellow and blue. They tend to confuse greens and blues, and yellow can appear pink. This is the rarest of all dichromacy, and occurs in around 1 in 100,000 people. Patients do not have the blue cone cells in the retina. Testing for dichromacy. The three determining elements of a dichromatic opponent color space are the missing color, the null luminance plane, and the null chrominance plane. The description of the phenomena itself does not indicate the color that is impaired to the dichromat, however, it does provides enough information to identify the fundamental color space, the colors that are seen by the dichromat. This is based on testing both the null chrominance plane and null luminance plane which intersect on the missing color. The cones excited to a corresponding color in the color space are visible to the dichromat and those that are not excited are the missing colors. Animals that are dichromat. It is more informative to use situations where less than the total visual system is operating when studying about vision. For example, a system by which cones are the sole visual receptors could be used. This is rare in humans but certain animals possess this trait and this proves useful in understanding the concept of dichromacy. While their Triassic ancestors were trichromatic, placental mammals are as a rule dichromatic. The ability to see long wavelengths, and thus separate green and red, was lost in the ancestor of placental mammals, though it is believed to have been retained in marsupials, where trichromatic vision is widespread. Recent genetic and behavioral evidence suggests the South American marsupial Didelphis albiventris is dichromatic, with only two classes of cone opsons having been found within the genus Didelphis. Dichromatic vision may improve an animal's ability to distinguish colors in dim light. The typically nocturnal nature of mammals, therefore, may have led to the evolution of dichromacy as the basal mode of vision in placental animals. The exceptions to dichromatic vision in placental mammals are primates closely related to humans, which are usually trichromat, and sea mammals, both pinnipeds and cetaceans, which are cone monochromat. New World monkeys are a partial exception. In most species, males are dichromat, and about 60% of females are trichromat, but the owl monkeys are cone monochromat, and both sexes of howler monkeys are trichromat. Color detecting abilities of dichromat. According to color vision researchers at the Medical College of Wisconsin, including J. Neitz, each of the three standard color detecting cones in the retina of trichromat blue, green, and red can pick up about 100 different gradations of color. If each detector is independent of the others, simple exponentiation gives a total number of colors discernible by an average human as their product, or about 1 million. Nevertheless, Other researchers have put the number at upwards of 2.3 million. Exponentiation suggests that a dichromat, such as a human with red-green color blindness, would be able to distinguish about 10,000 different colors, but no such calculation has been verified by psychophysical testing. Furthermore, dichromat have a significantly higher threshold than trichromat for colored stimuli flickering at low, 1 Hz, frequencies. At higher, 10 or 16 Hz, frequencies, dichromat perform as well as or better than trichromat. This means such animals would still observe the flicker instead of a temporally fused visual percept, as is the case in human movie watching at a high enough frame rate.
Please subscribe and thanks for watching.